I got to see very kind of from almost afar because the booth was so busy. But our friend here, Hans, from Thimio, has come up with what he calls the perfect clipper. And Hans, we'd like to turn it over to you and get started. Uh, if you're not already unmuted, please do so. And
Yeah, I'm really about.
Maybe
So,
actually before Hans, if you don't mind, I'd like to insert myself in here
you
for
are inserted.
just a moment, and then Hans will tell you about clipping and stuff. But the answer to that is, well, what if we made a box? Kind of like other processors out there. And so Hans was gracious enough to when I approached him and said, "Hey, let's build this box." He said, "Yeah, this would be great fun." And so the Stereo Toolbox was born. It is really well provisioned. Um, I'm going to just kind of walk you through some of the features, and then Hans is going to kind of zoom in on a couple of details, and then we'll zoom out and answer any questions. So let me just touch on a few of these things. This product has the perfect declipper in it. And many of you may have already heard about the perfect declipper because it's licensed for use in the Omnia 11 and the Omnia 9. What you may not realize is that the perfect declipper was written by Hans. He's the software genius behind this really magic piece of real-time um, I don't know what exactly to call it. The mastering engineers have decided they want their music in many cases to sound all smashed up like radio, and then we're supposed to take that smashed up audio and we're supposed to smash it up again through our processors. And Hans actually has written the algorithms that reverse that, and it's pretty staggering if you actually hear the work that happens, where you can listen to something that is clearly distorted, and it cleans it up and turns it, kind of restores dynamic range, removes the clipping, and so it's pretty amazing. Uh, we have the rule breaker clipper, which is the clipper that Hans has written for StereoTool. Is actually, this is the latest version. And in fact, many people are already familiar with Hans Clipper. Again, going back to Omnia, the Omnia 9 uses a previous version of Hans Clipper in their output stage. And there's a lot of people who believe that, and I've heard this from many engineers, they'll say that the Omnia 9 is, it's the best processor out there. It's super clean, super loud. And but what a lot of people don't know is the guy that created the clipper itself is Hans. So this guy is behind a lot of innovations in our industry, even by competitors, even by people who are licensing his technology to use in their own products. So he's a pretty significant figure that you may not have known too much about. And so we're hoping to change that today. Uh, we use an adaptive compressor on the front end. So it's a very natural compressor that adapts to the content. This particular product, the Stereo Toolbox, does FM analog output and HD1 output at the same time. So one box to do both. RDS is included. Pretty much every RDS flavor that is in use, that's popular, is used, is implemented here. We have a browser control. No programs to install, no Flash, no Java, nothing like that. You just open it up in a modern browser and you get a beautiful control screen. And we had built-in ratings watermarking. So in the U.S. that means Nielsen, and then outside of the U.S. that means a couple of other ratings services. I'll take you around the back, show you a couple of highlights here. We have analog inputs, analog outputs. We have digital inputs and digital outputs. so AES EBU. We have multiplex outputs, analog on BNC, and digital AES 192 on RJ45. We have a logic connector, so there's a couple of GPIO functions that we're able to implement. We have 2 Ethernet ports, one for control, another for something else, maybe. We have redundant power. We have an AC input for your main power, but we actually will sell you an optional, I guess it's not really a wall wart because it's huge, but we'll sell you a line lump power supply that you can plug into that DC plug, and it would be there in case the AC power supply ever failed or you lost AC. I guess you could even run it on a battery, but it probably wouldn't run very long because I think it pulls about 100 watts or some crazy number. A couple of the other things that I should probably point out, does have the diversity delay. So I did say that it's FM and HD1. Well, if you have that, then it requires diversity delay, and we provide that. And then one more thing, one more innovation that I should point out before we move on, and that is MicroMPX. So you've probably heard of MicroMPX. It is also licensed by the major processor manufacturers, and you've probably heard about this idea of multiplex over IP. And this again was invented by Hans, and he licenses it to pretty much everybody. I mean, everybody's using MicroMPX now. So and if they're not, they're talking to him about licensing it. So MicroMPX multiplex over IP means that you can put your processor at the studio and then use IP as an STL. It means that you can serve multiple destinations from a single source. So it adds a whole lot of interesting possibilities. So he can talk to you about that if you have any questions about it, but it does sound amazing. And then it has a $41.99 list price, which I think is astounding for this much functionality. Mary probably is going to give you the BDR special though, so I'm not even sure I'd pay $41.99. I'd twist her arm and make her give you a deal, at least free shipping or something like that. So that's the StereoTool box. That's the setup. And I kind of wanted to, give you the background. Hans and I have known each other for a long time. And so this is, for me, it's a joy to finally get to work with him on an actual product. We haven't been working together on products. We've just kind of known each other in the industry for a long time. And so I have to say that it's really cool to be part of this and to say, and also I'll just embarrass you a little bit, but you see, I have the joy of working with the 2 nicest and smartest guys in processing, So we've got Cornelius with all of his magic, and we've got Hans with all of his magic, and now we're all working together, and it's really a blast. So Hans, you can talk about whatever you'd like to talk about now.
Yeah, so okay. So Barry, how much time do I have approximately, so I know what to talk about?
Whatever you
To
like.
go through it.
Whatever you'd like. Would you like anyone to ask questions, to wait until you're done, or to just press spacebar and Alt A and chime in?
Yeah, just chime in.
Okay. Thank you.
So yeah, so I expected only a few minutes, but given the time, I probably have a bit more time. So I will probably start with well, what you mentioned is already the Declipper, and that's something that we made years ago. But well, that was actually how the company started. So we had that thing, and people saw it, and well, after seeing the response of many people to what it did, I basically figured I want to do this full time, and I want to do this for a living. And since then, yeah, we've been trying to come up with at least one thing that's new worldwide every year. So, for example, well, Mike already mentioned the RDS encoder, and today every processor that you see almost will have an RDS encoder, but we've had it since 2008. So that's a bit of a while ago. And we now also support RDS2, for example. So with RDS2, you can send things like logos via RDS as well. So we always try to find new things to do that nobody has done before. Now, yeah, one of those was, of course, the Declipper, but I will first focus on some other things that make our processor stand out. And one of the things that people probably are interested in is the final clipper. And yeah, Mike already mentioned it, and it's really loud, but let me just share my screen and go through a bit of background to explain why it is so loud.
It's really loud. You know, he just said it's really loud, and you know, you're thinking, yeah, it's really loud, but no. Corny called me, and he actually swore over the phone to me, which, you know, if you know Corny, he never uses bad language, to tell me how loud it was. And so this is really something.
Let me see if my screen sharing goes a bit more well, smooth than yeah, it looks like it. So okay, well, I guess you can see my screen.
Yes.
Okay, good. So basically, traditionally, what you want to do is you want to make an FM signal loud, but that has some big drawbacks. It creates distortion and it reduces dynamics. And especially with pre-emphasis, even more so in the US with 75 microsecond pre-emphasis, you lose a lot of highs. So you get a dull sounding end result, which, well, might turn people off. So what we want to do is we want to achieve loudness, but we basically don't want to clip, because the whole goal is to avoid clipping. Let me skip. Now let me go to this one, because this is a good introduction. So typically, there's one thing that you can do that's basically free. So typically, you clip the audio, you take the left and right signal, you clip it, and then you add the pilot and RDS on top of that. Now, if you look at the pilot and RDS, if you tilt the RDS by 90 degrees, then the sum of pilot plus RDS is just that tiny bit lower. And you can see it on this image. The left side is what it normally looks like, and the right side is what you get with the RDS tilted. Receivers will happily accept it. There's no standard that says that you're not allowed to do this, and it gives you not much, but probably 0.1 dB of extra loudness. But hey, it's free, so we'll take it. But then, when you start to look at what the signal looks like that you're actually sending if you clip this way, what you see in this image here is basically the gray area is the left plus right clip signal. Now, if you add the pilot and RDS on top of that, sometimes you go up and sometimes you go down. So the signal that you add is the wiggly line on top. And sometimes, but what it does is, if yeah, you can probably see my mouse cursor. For example, in this spot here, the pilot plus RDS goes down. At that point, we could have allowed more audio through, because, well, instead of clipping at this fixed level, we could have clipped at this slightly higher level. And that was the first idea that was like, okay, we can use composite clipping and that will do that. But it turns out that there are way more benefits that you can use. So here are my absolutely amazing images that I drew in Paint. So sorry for what they look like. I had some comments about that in the past. So anyway, I'm not going to replace them. So let's say that this is your left and right channel. And on your left channel, you have a peak, and on the right channel, you don't. And the blue line indicates the clipping level, and the grayish line indicates basically the center of the waveform. Now, if you were to clip this, you would get this. So, well, okay, that was my pen. We basically just cut off everything, and that's it. That's your traditional clipping. Now, what if we look at instead at the left plus right and the left minus right signal separately? So if you add the two up, you get the waveform that you see on the left here. So there is still a spike, but it's less high. And if you subtract the two, you just get the difference. So basically, what's my mouse? Basically just this blob here, which is what you see here. Now what we can do is, what stereo modulation does is you take your left minus right signal and you basically multiply it with a sine wave at 38 kilohertz. Now, there's a 50% chance that that sine wave happens to go in the opposite direction, multiply the two, and suddenly this thing doesn't go up anymore, but it goes down. So now if we add the signals that we got together again, so we take the left plus right and we add the modulated left minus right, then the resulting signal looks like this, and you can already see there's almost nothing above the blue line anymore. So if we clip this, we remove almost nothing. And if you then demodulate the end result, it looks like this. And that's very close to the original. So instead of what you see here on top, we get what you see here at the bottom. And this has a lot of benefits, which are also listed here. It's clearly a lot louder. You can see that. It's also a lot more dynamic because, hey, there were no spikes, no peaks, and now they are there. It sounds less clipped, well, because it is almost not clipped. What you also can clearly see here is there's much more stereo. Because, well, here the two signals after clipping were same level, but now we basically retain the stereo information after clipping. And because this mainly affects short spikes, because the whole spike needs to be flipped around by the multiplication with the sine wave, it basically only affects highs, but it means that you can squeeze through a lot more highs, and a lot more means, I've measured it, if you just send through white noise and you don't care about audio quality, which of course we do, but if you don't, then we could squeeze 5 dB of extra highs through, basically, compared to traditional clipping. But there's more, because, okay, now at this point, we are basically editing the whole composite signal, the total signal that comes out of the processor. And that means that we can do some more things. And one of those things that we can do is we can actually, in the software, act as if we have an FM transmitter, perform the exciter step that the FM transmitter would do, generate the RF signal, and then run a spectrum analyzer on that and look what our spectrum looks like. And if the spectrum gets too wide, we can actually intervene and make it less wide. This has some effect on the audio, but it's very little because we know exactly which things in the spectrum are causing issues. And this, again, has lots of benefits. First of all, well, if the signal is too wide, you're basically transmitting in a place where your receiver isn't listening, so you're wasting power. You might also be causing interference to other stations. If a receiver actually tries to follow the wider bandwidth, it's listening to a wider range, and you get more multipath distortion. And something that I didn't even list here, but I've heard it now from so many people that I think I can safely claim this. It protects your HD1. So I think it's called the BER, the error rate, goes down to 0 basically if you turn this on. So lots of benefits of this, and we can do all these things because we have access to the full signal. Now, this still wasn't loud enough, so we figured out something else. Typically, if you look at your RF, at your composite signal, what you have is you have your left plus right signal. That's this part here. You have your pilot. Then you have the left minus right signal, and you have the RDS. Now, the left minus right is normally symmetrical, but it doesn't need to be. Radios don't care. So what if we play with that? Well, it turns out that if you can actually modulate the signal on the lower half or on the upper half and just multiply it by 2. And if you do that and you compare the resulting signals that come out, you can see, this is the 2 different versions, that the peaks are higher on one than on the other. And sometimes this one is lower and sometimes this one is lower. So if we continuously switch between the two, we can actually avoid another dB of clipping. So the end result of that typically looks a bit more like this. Sometimes it's symmetrical and it tends to go down on the right side, which is actually also helpful with reception again, because having more higher frequencies is typically bad for reception. So it's good that it's slightly asymmetrical in this way. Now, what does this look like? It's probably not very useful to play audio, and I don't have any samples prepared here, but let me just show you what the demodulated audio looks like. So traditional clipping, you have left and right output, and here we're looking at the demodulated left channel. So traditional clipping looks like this. We have a signal that's very tightly cut off at a specific volume, and you cannot go over that. Now, composite clipping without the single sideband, dual sideband switching that I just described already looks like this. So you can see how much more spikes are getting through. And this is with actual audio. So this is not a drawing that I made in Paint. This is actual audio that we fed through. And if we add this upper and lower sideband switching, it goes even higher and it looks like this. So you can imagine just looking at the waveforms, how much better and how much louder this will sound. Here are some other songs that are, I mean, this one was actually, the last one was actually recorded too loud, so I should have given it more headroom to show, but you can see that it's actually louder than what this image can show. And this is clearly multiple dBs of extra loudness and extra dynamics.
Hans, can I ask you a question about the SSB? You called it opportunistic switching.
Yes.
How often is that happening between SSB and DSB?
Constantly.
Oh,
it happens probably multiple times per millisecond.
Okay.
It's just
cool. Thank
constantly
you.
going up and down.
All right.
Now the cool thing, because we can we create this really clean signal that's so well controlled. We've heard from multiple stations that after switching over from other processors, some of them had up to 30 miles or 50 kilometers bigger stereo reception range. Then of course that doesn't happen if you have interference with other stations, but even in the Netherlands here where the dial is completely filled up, we've heard from people that they had better stereo reception further away from the transmitter side. So yeah, that's the Clipper, which actually transitions nicely, and I should probably speed things up a bit, to MicroMPX, which starts here. So we had this really nice way of getting a signal, of generating the signal, and then people were afraid to run StereoTool at the transmitter side because they had to run a PC typically with Windows, and then some PC at the transmitter side would start to do Windows updates, and they would not be happy with that. So many people were using StereoTool and then still sending left-right audio to the transmitter side, and then you lose basically, well, it's typically 2 to 3 dB of loudness on average that you're losing that way. If you use the composite clip, and then you can't use it anymore. So we needed a solution for that, and that's how MicroMPX came about. So basically, we wanted to make a codec that's specifically designed for MPX, because without a codec, well, you can send a signal over line, but you would need at the very least 2 megabits. And typically, with most codecs that existed before we made this, it was at least 4, and sometimes even more than that. And well, if you have a transmitter that's somewhere on some hillside with pretty poor internet, then that's not going to work, especially not if you have multiple stations there. So we had a few requirements. We wanted to have all the benefits of composite clipping. We wanted the extra loudness. We wanted the Stocker mask. The Stocker mask is, by the way, the control that's used to control the RF bandwidth. So that has to survive the codec. Otherwise, we're losing reception quality, and we don't want that. Obviously, we need perfect peak control. We need the very clean signal that has the bigger reception area. and we don't want any perceivable audio quality loss. So basically what we set out to do was make some codec that would not have any perceivable difference compared to putting your processor at the transmitter side. At the time, we didn't even think about the fact that this means that you can use one processor and have 100 transmitter sites that just have a decoder at that location. It was just intended to just get people, make it possible for people to have the much better audio quality. Now, the last thing was, well, we want a low bit rate, but only if it fulfills everything above. So we wanted to make sure that it would basically, if you listen to it, you shouldn't be able to hear it at all. So how does it work? Well, you have an FM processor at your studio. If the FM processor, like the StereoTool box, has MicroMPX included, that's just all you have here. No separate RDS encoder, nothing. It's basically just your processor. And the signal goes through the network to the transmitter side, where similarly, if the decoder is built into the transmitter, then you're immediately done. That's it. If it's not, you can add a MicroMPX decoder at the transmitter side, but still you wouldn't need an RDS encoder. You wouldn't need everything else, a stereo generator. It's just one thing, one very small box often, and that's all you need. Let me flip through this quickly. Yeah, the codec is designed for FM, so we definitely do not want any MP3-like artifacts in it. And it's also, because of that, a completely different codec, which also, as a benefit, which we didn't anticipate at the time yet, but means that it cannot affect things like watermarks. So don't worry about your watermarking, that it would be affected by this. It's not. Oh, and we also wanted maximum stereo separation, so basically no degradation of anything. Also, the RDS signal must be perfect. Let me just switch through this because, yeah, so we made that, and that's MicroMPX, and I'll go through where you can find it in a moment. For people for whom we ended up at a minimum bit rate of 320 kilobit after doing lots of listening tests with dozens of people in the Max Planck Institute, and was a lot of fuss to get it all arranged. But in the end, it turned out that at 320 people couldn't hear anything. But sometimes 320 might not be low enough. You might need to be able to go even lower. For example, if you want to send your signal over satellite, over a 4G or 5G connection, or if you just have a very low bandwidth connection to your transmitter site where multiple stations are co-located. So for that, we made MicroMPX Plus, and MicroMPX Plus is basically a version of MicroMPX which is much more aggressive. Much more aggressive means that we do use some techniques that are used in traditional codecs like MP3 and AAC. We combine it with how MicroMPX already works, so we have the benefits of both, but it does break a few things, and one of those is we cannot no longer guarantee there is no effect at all at the RF bandwidth. Now, we have the only clipper that even handles the RDS, the RF bandwidth in this way anyway. So if you use other clippers, then it doesn't matter, but still, yeah, there are some small drawbacks to this. But if you use this, you can go down to 176 kilobit and still have the full composite signal with pilot RDS. Even RDS2 is included. If you want to have RDS2, then you need to go to 192 kilobit. So where can you find it? It's built into a bunch of audio processors that you can see here. It's also built into a number of encoders and decoders that you can just buy, and these are typically all interoperable. You can also, if you just want to do a cheap do-it-yourself version, there are, I think at this point, probably around 1,000 stations on the air that use Raspberry Pis, and those things are stable, so you can also use those. Oh, and this list is no longer complete. BE should be added to this, but yeah, there are also a bunch of transmitter manufacturers that have it built into their transmitters. Oh, and Syntec is also missing from this one, so multiple are missing, and this list is going to grow soon anyway, but this is what we currently have in this presentation. It has built-in error correction, and the next version that we're going to release will also contain RIST support. RIST is a error correction. It's not really error correction, but it's a standard that's coming from the video industry, which has as goal to make the streams much more reliable. And basically, I've heard from people that up to 80% packet loss, they still get a basically complete signal with no dropouts. So, oh yeah, and it said released, but we had to pull it back, but it's coming soon. We can also support single frequency networks. So if you have multiple transmitters at the same frequency that have overlapping reception areas, then we can synchronize them down to under one microsecond. And that's basically all I wanted to say about MicroMPX, I think. Yep. This might be a good moment to ask if anyone has questions.
Well, first of all, was this the first year you've shown at the NAB?
No. We've been there since I think 2013 or 14.
Okay, but we really haven't heard much from you, and as Catfish says, you've been built into other boxes.
He's kind of the most famous processing expert you've never heard of.
Well, we've heard of him now.
Of course you have. Yeah. But and anytime you think of StereoTool, you need to think of Hans. But even beyond StereoTool itself, there are all kinds of other interesting innovations, software innovations out of Timio that are kind of ubiquitous.
Where's your factory, Hans?
Well, we don't really have a factory because most of what we do is software. So any hardware that we do make is made at another company, but we are located in the Netherlands. Yeah, that's it basically.
Okay. Does anyone have any questions for Hans about the StereoTool or the Clipper?
Yes, I do. Okay,
Please.
so some folks with spoken word and whatnot will take their FMs and switch them to mono to sometimes gain a little bit of reception area. Are you saying that this box can leave the transmitters in stereo and have a better net effect on reception?
No, because this specific case is the stereo hiss that you hear on some receivers.
Okay.
So that's the issue with that. The stereo hiss itself, of course, will not benefit from this because, well, the receiver needs to decode it, and that hiss is just there. So that's just physics. There's nothing we can do about that.
Okay.
And if you have mono audio, then it really doesn't make much difference because then we also cannot gain much with the composite clipper. So we can also not make the audio louder. So we can do that with music, but with spoken word, the effect is much smaller.
Very good. Thank you.
Now, one thing I do want to say is there are some stations that switch back and forth between stereo and mono, and that might be feasible. But there are some receivers that really don't like it, and once they've lost the pilot, they will never go back to stereo. So just be aware of that if you do that.
Okay. Anyone else? Questions? This is the time. You don't have any comparative audio setup, do you, Catfish?
No, actually, on the Timio website, I do know there's a sample of the Declipper that you can listen to, the Declipper, so you can actually listen to before and after, it's a pretty shocking little demo. So doesn't take a long time. It's like a 30-second thing, but you'll be pretty amazed. I would go there. Timio.com, THIMO.
That thing is at declipper.com, but I think, and let
Is
me
it?
check. I think there was an issue yesterday with the. Oh, it's not reachable. What the hell? One moment. Okay, so yeah, I noticed that yesterday something is wrong with the SSL certificate. But if you go to perfectdeclipper.com, so put perfect in front of it, then you will find it.
Would you like
but I
to
need to
demonstrate?
fix the. I could do that. Let me. How do I share this with audio? Does that just work?
Yeah, there's a little click.
Oh, share sound. I see it here. Yep.
Mhm.
Okay. So let me go back here. Let me just do this live then. That's probably more interesting than seeing a video that's. Sorry about Winamp, but that's. Okay, that's taking way too long. Let me go to the site anyway then. Oh, here we have. Oh, it's coming. I think it was probably. Check if things are set up correctly, and then I can do the audio. Sorry, one moment. This will be done quickly, but I just need to make sure I have to correct. Oh, wow. I'll take it from the side. So can you hear that audio?
Yes.
Okay, good. So here's a bit of, well, you'll hear what it is.
How about getting off of these antibiotics? How about getting off of these antibiotics?
Well, these are things that I obviously clip myself, so that's not the most convincing demo because you might not believe it. So let me go to this one.
Well, it's certainly good to gather here. It's been a long time in coming and one that we've looked forward to.
So there's this guy who films weddings, and he came home with this, and he kind of panicked and sent us the recording, which was great because it's great demo material. If I go to the Declipper and enable it, and I have to raise the level because it's really insanely clipped, and I turn it on again.
Well, it's certainly good to gather here. It's been a long time in coming and one that we've looked forward to, and the day is here.
So yeah, that's basically what it does. So it fixes it. And this here is like 20 dBs of clipping, so that's quite a lot. But yeah.
Okay. I'll just mention that when I post this video, probably tomorrow, we have to make sure that the internet gods on YouTube, they sometimes block a video if there is copyrighted audio.
Yep. So I don't know if this. I have a video online with all these songs in it, and it hasn't been taken down yet. So it's
Well,
been there
good.
for like 15 years now. So.
Yeah, let's hope that we're okay.
So the other thing, if we have some time left, I don't know if you have anything else or.
Any other questions, folks? Go ahead, Hans.
I mean, I can go through the new Clipper design, if the new compressor design. Sorry.
Sure.
Okay, so and I don't have that much time left, so I'll go through this quickly. But we made this new adaptive compressor, and typically what you do if you control the level is you have an AGC, and the AGC is slowly adjusting things, and then you have a multiband compressor that's doing things faster, but typically at a lower ratio. And then you get sometimes even another multiband compressor after that, all of that to basically tame down the signal and make it all sound the way you want it to sound. But that's problematic because, for example, if the AGC goes down quickly and the multiband goes up slightly less quickly, then you have a gap in the audio. And yeah, so all these things need to be tuned to each other to sound good. More paint drawings. So yeah, so typically if you suddenly have this loud bang in the audio and your AGC starts to move it down, then you have this bump left in your audio after the AGC. Put thread through the compressor that reacts too slowly, and what you get is basically a drop afterwards, and yeah, this effect. So that was what we started with, and basically I wanted to get rid of everything and just have a single stage, single loudness stage, basically single dynamic stage. So instead of having an AGC and multiple multibands, I wanted to have one thing that just fully controls everything and is smart enough to sound good on its own. And yeah, let me go through, skip through this. And one of the things that you want to that's really tricky is, for example, audio like this. For example, here we have very short, loud spikes. And then after that, you have loud, sustained audio with a brief, quiet section in between. And typically what you want for this is, if you have these spikes, then the audio in between, you don't want to have the audio drop down after the first spike and be gone completely. So here the audio needs to come back very quickly. But here, where it's sustained, if you bring back the audio quickly, then audio dynamics are gone. So you don't want that. So after playing with things a lot, and this here is bad behavior that you could have if something is really badly tuned. Let me just go through this and show you what we can make of this. And here you can see this here is a pretty small effect on the loudness compared to all this pumping here. So the pumping is basically, this is so little that you basically don't hear it. But here with the audio that's already sustained all the time, you can see that the quiet section is not pulled up anymore. So we are basically just fully adjusting the behavior to the incoming audio. If it's dynamic, we move fast. If it's not very dynamic, we move extremely slowly, with as a goal to basically be inaudible. And this is all way too much detail to go into right now, so let me skip that. So yeah, that's the one last funny thing. So this thing can run on its own, and it can run at infinite ratio. And the cool thing about that is that you get way more consistency than you would otherwise get. Because, for example, if you have a song that doesn't have a lot of bass, if you have an AGC that's slowly controlling things and the level goes down, then the multiband, which is typically running at a lower ratio, will never fully be able to get the bass back up. Because this new design can run at infinite ratio, you don't have that issue anymore. So we can fully bring back the bass and the highs if they're not there, as far as you basically allow the thing to move compared to the average of the total of the audio. And the result of this is, as I said, much more consistent audio. And also the whole thing was made to be inaudible. And basically, typically the idea is you should be able to turn this thing up to infinite ratio, give it 40 dB of levels to work with, and still you should not, if you turn this something on and listen to it, you should still not think, hey, this sounds compressed, because you should not be able to hear it. That's the whole idea of this design. But you might still not like the idea of having infinite ratio. So we have something for that, which is parallel compression. And what you can do is you can put two compressors not after each other as you would traditionally do, but you can run them in parallel and the output will be combined. And if you run them at the same level and at the same with the same output level, etc., then basically each separate compressor is only attributing about 1:2 ratio to the end result. And at 1:2 ratio, you probably know you can get away with almost anything. But still the end result is fully consistent. So traditionally you would put, for example, two 1:2 ratio compressors after each other to get 1:4. Now you can put them side by side and you get still infinite, but the effect of each one is still only 1:2. So that was the parallel compression thing. Yeah, I can play a bit of audio with that. Let me see where I have my recording that I want to play. That was this one. Yeah, this one might be a problem for posting. But for people who are listening live, have this song by the police. Let me zoom out so you can clearly see the waveform that's going out and that's coming in. If I turn this into lifetime, then you can hear the original, and you will now hear how insanely loud these kicks are. So this is one of the most difficult songs to process properly because this will often cause all kinds of issues. So let's have a look back here. Oh, let me also turn off the noise so we can hear everything fully. What you can see if you look at the meters here is that they're actually jumping up and down, often more than 15 dB on these hi-hats and bass kicks, but it doesn't sound like it. So yeah, that's basically the idea of the new compressor.
Very good. Seems like processing in some ways we've come back round to what we were doing back in the late 60s, early 70s with the DAP and running two of them at the same time. But I like the way that you've talked about the adaptive compression. That's really an important thing, and I see a few manufacturers starting to bring some of that in.
I have nothing left, so
All right. Any other questions from the group here? Folks, are you all mesmerized by the sound, or do you have a question as to what Hans is doing?
No, I understand what what this should sound like. So I'm assuming that the issues I hear are from Zoom.
oh, we
Be
did not
likely.
test if Zoom is doing anything. Oh, okay.
Yeah, Zoom gets busy. It's got
Aha.
noise cancellation and all kinds of stuff going on. Not to mention the codec, So
Yeah, it does. It does. So obviously, we'd like to recommend folks go right to the site and listen to it directly.
Yeah, that should be much better.
Okay. Yeah, we should have tested that.
But looking at the waveforms, looking at the band compression levels that you're showing, it's obvious what you're doing, and I think it's a great aspect. We're not worried so much about the modulation wars as the cleanliness of the audio.
Yeah.
Well, it is crazy loud. So, if the wars still mattered, I think this Clipper might just win. But it's super clean. And so
I think a lot of it depends upon the radios in the vehicles. For instance, I know that AGC has been introduced into a lot of the vehicle sound systems because switching from radio to streaming to flash drive or whatever, you've got levels that are just all over the place, and now the radio's dumbing down a little bit.
Well, it's clear to me that none of the stations in my market are using any of this.
Well, Mary is offering a free demo to anyone that would like to have that and put it online and do some A/B comparisons. And I think you're going to have a hard time talking the program director and sending it back.
It hasn't happened yet with boxes that we sold, at least. I keep trying to get a demo box to send to people, but yeah, always have to send a new one. They never come back.
Well, that's probably the best recommendation you can get.
Oh yeah, this is an interesting one that I should probably mention. So there was, I don't know if I'm allowed to tell you which market it is in, but there was a big market with 17 million people or so. It's not the Netherlands, by the way, because that's also that number, but it's a big market with that kind of people. And there was this one station that was I think they were number 3 in the market, and they switched to our processing. They were the first to do that. And 2 months later, they were number 1, and nothing else changed. So,
I like the way you said that. They were the first to switch to our processing.
oh yeah. Oh yeah, I've been
No,
there, and
everyone in the market follows. I always enjoy
yes,
that. That happens.
that's the thing. I mean, that's the thing with this. You have to get one station to start using it, and then same
Well,
thing
I've
with
seen that
MicroMPX, by the way.
seen that all through processing history. You know,
Probably, yeah.
starting with the Max Brothers, and then the DAPs, then the Optimods, and CRL, and Omnia. Now here, this is the another step that I see, and it makes a lot of sense.
Well, without a lot of fatigue, you're going to see that.
There is a letter to it was to DB Magazine, which I don't think exists anymore, but it's a letter that I read, and goodness, this goes back a number of years, but I cut it out and I saved it, and it's somewhere somewhere in this office. And it basically was the letter, tongue in cheek, about the station that installed one of the early clippers. And something about the problem was that the time spent listening dropped down to 15 seconds, and the alley filled up with the unused peaks.
Hmm. It happened often.
Yeah, they went too far, went far too far. You were talking, Hans, about dynamic range, and I think we've talked about this when Potomac Instruments came up with a box to measure that, and some of the stations in New York didn't even have a single dB of dynamic range.
Wow.
Oh, you're telling me that people in New York would do that? Would do that? I spent 22 years in New York.
Yeah, you were probably one of the ones you put the music in a box and then stepped on it.
No.
Squish.
No, I was fortunate. I had engineers who were very golden earish.
Well, Tom Ray definitely tried to keep the audio crisp in the last years.
Well, WR always sounded pretty good, but I'm thinking FM quality.
Mm-hmm.
And, you know, we were talking about some of this last week with how discouraging it is to see the degradation of audio and radio. And, you know, this, if they clean up the audio, my bet is that numbers would dramatically increase.
I think it was about close to 10 years ago now. Hans, you may correct me if I'm wrong, but I was at IBC, and that's where Leif was demonstrating the Declipper, and wow, it I saw that coming.
Well, I had a question about the Declipper. I think we all know that the audio coming from the studio is not heavily processed. And then it goes to mastering, where it's all smashed and mashed. Now, can the, you know, for vinyl and for CDs, can the Declipper return that audio to what we got from the studio?
If what they did is clipping, yes.
Okay, then that would be a real, I hate the term game changer, but
Yeah,
well,
it makes a big difference. It's like you heard that very last audio clip of the person talking, and then with the declipper, the distortion was not totally gone. Of course,
No,
that
not
may
with that
be
one, but
because
that was
of
20 dB.
you did what you could in the 3 seconds, but it was much clearer, much more intelligible, and
For
that would go for the audio. That would go for the
yeah,
music.
for typical clipping levels, like I mean that one recording is insane because they've used 20 dB of clipping or something, and that also happened probably in the hardware itself as well, maybe even in the analog microphone, who knows. But for music, if there's a few dBs of clipping, which is typically what you get, then basically the end result sounds as if it had never been clipped.
Do you use any AI in this process?
Depends on how you define AI. I mean, as a marketing term, I could say yes. I mean, there are ways to defend that we are, but not really, no.
I wonder how you would do that.
Well, I mean, you could.
I think you're analyzing the audio much deeper than AI would.
I'm not sure how far you could get. I mean, certain things might be possible to do with AI depending on how you train it and how you set things up. But yeah, I mean, for example, the Declipper is something that's for the Declipper, at least you know what the end result has to be. So you can feed it with a lot of audio and you can clip it and tell it, hey, I want back what I had originally, and you could train it that way. Yeah, but still, I mean, you can do it without AI as well, and then you know exactly what it's doing. So yeah.
Sure. You go back, go back 100 years, and you had a board op, and that guy's hand was on the pot the whole time, and his job was to make sure that it stayed up and yet not kick the transmitter off. And it's interesting to look at some of the transmitter logs in the 30s, and it talks about how many times that the transmitter shut down because of modulation. And then we bring it forward to our time today, and now you've got people that like the way that tubes will take care of peaks, and this is something that you're kind of emulating, and part of this with the adaptive compression and clipping. And so you're trying to take a very complex waveform and you're trying to look at it and see what you need to do to get rid of those peaks that, when they get clipped, make everything sound bad.
Well, except that we can clip them quite hard before they start to sound bad, so that also helps.
Yeah.
So we tend to, in our processor, send way more peaks into the clipper than many other processors typically do. So that also helps, of course, with getting a much more dynamic sound out of it.
I do have a local station here who's got an alley full of clipped peaks, and we could send them to you if you needed to graft them on or something. Hans, I really appreciate the information and the demonstration that you brought us. And Catfish, we always like to have you around.
I'm like the Dalmatian on the fire truck, Barry.
Yeah, well,
I'm not that useful in the conversation, but I look good on the truck.
whoa,
So there you go.
you really are making me angry. Hans, thank you. I hope we'll have you back before too long and do some more.
Sure, perfect.
Thank you, Barry. Thanks for
Yeah, thank you.
thanks everyone for inviting us today.
Yes.
All right. Take care.